All right, here we go. So, hello everyone. We are going to be talking about Newton's third law today. We've talked about Newton's first and second law. Newton's first law says that every is the law of inertia, meaning that if you have more mass, then this object is going to resist movement. Okay, so talking about inertia, remember more mass, more inertia. If we have less mass, less inertia. It's easier to pick up a 5-pound weight rather than a 10-pound weight. Then we have Newton's second law, and that's the one that we just did our CSA on, which is the law of acceleration. So the acceleration of an object depends on two things, and that's force and its mass. And we can find its acceleration using the equation force equals mass times acceleration. Today, we are going to talk about Newton's third law. And Newton's third law is very conceptual, so I need you to bear with me. If you don't understand it, when I get back, then we will actually be able to, I can explain it a little bit more, and we can do some practice on it. But Newton's third law is known as the law of action and reaction. So every action has an opposite and reaction. We talk about this just like in behavior, but it's also when we are talking about objects. So right now I'm sitting in my chair. As I'm sitting in my chair, my butt is putting force on the chair. And then the chair is putting force back upwards on my body. So it's happening instantaneously. It's two separate objects and they are exerting force on one. It's very different than if we were talking about net force and if net force is 0. So when we talk about net force, we have one object and we have a force pushing this way and a force pushing this way. All right. This, in this case, is we have two objects and they're putting force on each other. Now, what is the definition? The definition is every action has an opposite and equal reaction. So if you push on something, that something is pushing back on you. Newton's cradle that you can see here, this little illustration here, is an example of Newton's third law. Because the first thing is the farthest marble is going to hit the 4 marbles that are next to it. And that's the action. It's putting force onto the marble. Then the second part of that is that energy, or what it's actually called momentum. The momentum is transferred through the marbles into the 4th marble, and that, or 5th marble, 4th marble, whatever. Okay, the other marble on the other side. So as it transfers the momentum, it is going to push that marble back out to the side, and it continues forever and ever. So Newton's third law is really about having a mirror. So as one thing does something, the other thing is mirroring it back in the opposite direction. Now, what does this really mean? This means that we have one object that's going to exert a force on another object, and the second object is going to exert a force that is equal in strength and opposite in direction for the first one. Now, I want you to put your hands together like this. So when we clap, what do we feel? We feel a force. We feel force on both of our hands, okay? The reason for that is because as they touch, if we slowed time down very, 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 very slow, okay? If we slowed time down, we would experience that a force from our right hand is exerted on our left hand, and the left hand is exerting the same force on our right hand. When we have our hands set just like this, our right hand is pushing our left hand to the left, and our left hand is pushing our right hand to the right. So it's happening at one place. Now I want you to think about, how do you go up the stairs? If you're going up the stairs, you are going to step on the stair and push yourself up. But where is your force going? Your force is actually going down. So how is it that we are moving upward when we're pushing down? That is the action and reaction pair. Okay, so the action-reaction pair says that as I step down on the stair is going to push me up, and I am going to move upward. Okay, we'll get into it some more. So we've got a baseball player here. Let's pretend that we've slowed time down to the minute that that ball is going to hit the bat. So what is our action? What's the action happening right here? The guy's hitting the baseball. But we need 4 things in order to describe our action-reaction pair. So when we talk about the action, okay, the action force, or let me make sure I have that right, the action, okay, portion, we need 4 things. We need an object, We need to tell if it's pushing or pulling, and we need to tell if it's what direction and the other object. We have to mention the other object. So looking at the bat and the baseball, here is the example. The bat pushes the ball to the right. So the minute that it makes contact, the very, 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 very second it makes contact, the bat is pushing the ball to the right. Now, what is the reaction? What's the reaction the ball has? Well, we just flip it on its head. We need 4 things. We need the new object, the push or pull, tell me what the force is, the direction, and then the other object. So if we flip it, we have the ball pushes the bat to the left. Okay? Now we've got 2 more on our sheet. We have the bike pushes down on the ground. So the bike pushes the ground down. Okay? So what is it that the ground is now doing to the bike? Well, again, we just have to flip it. We're taking a mirror to it and trying to see. So we are going to start with our object. Our object is the ground. Okay? The ground, what's it going to do? It's going to push where? Up on what? The bike. Again, it is just a flip of it. It's just flipping. Okay, our next one is the fish. Now, if I'm going to be totally honest, the fish sometimes can get very confusing, even for me at 30 years old. Okay, so the fish pushes the water backwards. I think side to side because the tail's doing it, but in reality, it is pushing the water backwards. So I'm going to do this a little bit differently after we talk about it. So fish pushes the water backwards. What is it? What's actually going on? I want you to think of a swimmer, okay? So when we're swimmers, and y'all know I swam in college and prior to that, so when swimmers are swimming and they're doing freestyle, it's the easiest one to talk about, they are going to put their hand in and they are going to pull the water backwards. Well, how is it that they're moving forwards? That's because the water is going to push them forward. So if we look at the fish one, the fish pushes the water backwards. Okay, let's start with our new object. Our new object is the water. The water, what's it going to do? Is it pushing or pulling? It pushes. Then, what is it pushing? It's pushing the fish. And then the opposite direction is forward. So we have the water pushes the fish forward. Okay, last one. And I'm going to show this to you on the screen so that you can see it and make a little bit more sense too, and you'll have a chance to write it down as well. So, a tennis ball hits the ground, and the ground hits the ball with equal force in the opposite direction. Where will the ball go next? Draw its new location. So, what I want you to do, I want you, use your finger, and I want you to trace where you think the ball is going to go. Okay? Where do you think? Remembering that this is an opposite and equal reaction. So it has to be opposite and it has to be equal. So when you draw your arrow, you need to make sure that it is the same length and facing the opposite direction. Go ahead and do that. Okay, do that. If I was in class, I would tell you, please stand up when you get done. But since we're not going to do that, you'd look really silly standing up right now with everybody else there and no one telling you what to do. Let's just trace it with our finger. So where do you think it's going to end up? Once you've drawn it, this is how it should look. So we have the ball going here, and it's going to go down. Now, why is it not going straight up? Well, that's because the opposite force is mirroring the original force. So it hits down and then goes back up. So I'm going to put this here. If you need to pause it, and let me see if I can get this. Nope, can't. Okay, I will put a picture of this on Schoology as well under the notes category, so you can look there. But, all right, our last one that we're going to talk about is this rocket. Okay, so we're not going to really explain why it's an example of Newton's third law, but we are going to talk about the action and reaction pair. The other thing I want to say is this is a lab that we're going to do at the end of the quarter, and I'm really excited about it. It's our balloon rocket lab. So you're going to you will be tasked with taking a balloon and trying to deliver as many paper clips to the ceiling. Okay, it's super fun, and it'll be a fun way to close our semester or our quarter, or until fall break, whatever you want to say. So looking at our rocket, what is the first thing that happens when a rocket takes off? Well, that is it's going to start burning fuel. And what happens is it creates what's called thrust. Thrust is a force that shoots downward. Okay, it's going to shoot downward. That is our action. So the action pair is the exhaust or the fuel pushing down. Now, what is it that the reaction is? Well, the fuel is pushing down on the air. Okay, it's not pushing down on the ground, it's pushing down on the air. And as it pushes down, what's going to happen to the reaction? Well, the rocket is going to fly upward. So our action pair is the exhaust pushes down on the air and the air pushes up on the rocket. So again, we are going to do so much more practice when I get back. And if you're confused, I can just send me a message on Schoology and I can find some videos that'll help you along with some things that we'll do when we get back. So as a reminder, while I'm gone, make sure you get all your work done. You don't want a 0 just because you decided to goof around. Number 2, if your name's written down, you will receive a detention. And just be on your best behavior, guys. Just do it, chill out, and y'all got this. Remember, stay curious. I'll see y'all later.